So I'm the first presenter for our group 4. And our topic is all about process in operating system. So process. Early computers allowed only one program to be executed at a time. This program had complete control of the system that had access to all systems resources. The process concept questions that arises in discussing operating systems involve what called the CPU activities. So in operating system, the process is something that currently under the executions. So yeah, an active program can be called a process. Let's say example is when you want to search in a Google or web browser. So that's is called process. So when you want to open a PowerPoint a software, that's called process. So next we have the three process. First is process. The process more than the program code, which is something known as the text sections. So this process, we have the process memory is divided into the four sections, wherein we have stacks, heap, data, text. So stacks is used for a local variables. Space on the stack is reserved for local variables when they are declared. And the heap is this is a dynamically allocated memory to a process during its runtime. So we have this data sections is made up for global and static variables allocated and initialized prior to execute the main. And lastly, we have the text sections, wherein is made up to the complied program code. So next is this the process states. So as a process executes, it changes states. The state of a process is defined in part by the current activity of that process. So the process may be in one of the following states. First, the new states when the process is first is created or started. So next, when the running states. So this states is the instructions are being executed. So nagpo-process na siya. Yeah, running the process sets to running. Uh, Next is waiting states. Uh, this waiting is the process move into the waiting state. So if it needs to wait for our resources, such as waiting for a user to input. So next, the ready states when the process waiting to be assigned to a processor. So this process waiting to be assigned. So now it's ready na siya. So naghihintay lang siya for allocated. Uh, so next we have the terminated. So this terminated the process being finished, or this is the process when it's completed. So next is we have the process control block. So each process is represented represented in the operating system by a process control block, also called a task control block. So specific process include this uh, process states, program counter, CPU registers, CPU scheduling informations, memory management information, accounting information, and IO status operation informations. So this is a process in the process states when it can be a running, waiting. So like this process states like I discussed kanina, and program counter when hold the address of the next instructions to be executed for for that process. and CPU registers. And this register that are used by process, they may include accumulators, index register, stack pointer, general purpose, and etc. This the and next is the CPU scheduling. When CPU schedule in the task performed by CPU that decides the way process will be executed, determining which process will own CPU for executions. So, siya yung nag-manage ng memory management. I know, the schedule information rather. And next, the memory management information, wherein memory manages process of controlling and coordinating a computer main memory. So this siya nag-manage ng informations in the main memory. For example, is when page tables, segment tables like that. And next is the accounting informations. And next we have the devices. I mean status information, so I/O status informations. So these formations include the list of I/O devices used by process, the list of files, tables, I mean files, and etc.
Scheduling queues. As process enter the system, they are put into a job queue, which consists of all processes in the system. So, what are the scheduling queues in operating system? So, there are three types, which are the job queues stores all processes that are entered into the system. The second, the ready queues holds processes in the ready state. And the last one is device queues hold process that are waiting for any device to become available. For each I/O or I/O device, there are separate device queues. So, example, job queue. This queue keeps all the processes in the system. So, which are ready queue. This queue keeps a set of all processor or processes residing in main memory, ready and waiting to execute a new process in always put in the for this queue. Schedulers. A process migrates among the various scheduling queues throughout its lifetime. Scheduling proposes processes from this process is this queues in some fashion, so the selection process is carried out by the appropriate scheduler. So some example of using scheduler are database administrators can schedule and monitor database maintenance jobs such as backups or nightly data warehousing loads and extracts. So application developers can create programs which the program libraries that end users can use to create or monitor their own jobs. So there are three types of scheduler, which are the process schedulers are divided into three categories, which are long-term scheduler or job scheduler. So the job scheduler is another name for long-term scheduler. The second is short-term scheduler or CPU scheduler. CPU scheduler is another name of for the short-term scheduler. And the third one is medium-term scheduler. And the last one is context switch. When an interrupt occurs, so the system needs to save the current context of the process running on the CPU so that it can restore the context the it is processing is done. So essentially, suspending the process and then resuming it. So, what is context switching in a simple words? Um, so, context switching involves storing the context of states of a process so that it can be reload when required and execution for the resume. So, from the same point of earlier. So, this is a feature of multitasking operating system and allows a single CPU to be shared by multiple processes. So, example of context switch. So, suppose that multiple processes are stored in a process control block. So, one process is running state to execute its task. So, with the use of CPUs, as the process is running, so another process arrives in the ready queue, which has a high priority of completing its task using CPU.
So let's move on operations on process. So by the way, I'm Giancarlo Piunio, BSCS for ADM. So the processes in most system can execute concurrently and they may be created and deleted dynamically. The system must provide a mechanism for process questions and terminations. So in this section, we explore the mechanisms involved in creating process and illustrate process question in even the process termination. So in process question, so for example, when a user opens a new program, the operating system creates a new process for that program to run it. And the terminating process or process termination is also when a user closes a program, the operating system terminates the process associated with that program. In executing a process, there can be child processes. A child process is a process that is created by another process, known as the parent process. The parent process can create one or more child processes which can run concurrently with the parent process. And the child process is a separate process from the parent, but it shares some resources such as, for example, memory, space, input-output, and file descriptors with the parent. The child process has its own unique process ID, which is the PID, or also called as PID, and can have its own set of instructions to execute. So one of the example of parent process and child process relationship is kapag nag-open si user ng web browser sa kanyang computer. So ang operating system is gagawa ng process for the web browser which is called the parent process. If the user is mag-navigate siya ng website na gumagamit ng JavaScript to display dynamic content, so the web browser creates a new process. So it's called a child process. So the parent process, which is the web browser, continues to handle the rendering and display of the website, while the child process handle the JavaScript interpreter. So if the JavaScript code is done, the child process may be terminated by the operating system or the parent process. So, dito naman tayo sa process termination. So, ang isang example nito is kagaya ng sinabi ko kanina kapag si user is nag-open ng web browser and nag-explore or nag-visit siya ng isang website or kahit anong website. So, the user decides to close the web browser. It needs to click the X button in the top right corner of the window or use keyboard shortcut to close the application. So the operating system receives the signal to close the web browser and it terminates the process associated with the browser. So the operating system frees up any resources that were being used by the web browser such as memory and file handles. So for another example of terminating a process can be when a software has a bug that causes the software to crash or to get stuck. In that case, the operating system will terminate the process associated with the software. So that process can also be terminated by the operating system in other ways, such as through the use of command line, utility, or system call by another process.
Example of IBC system. In this section, we explore three different IBC systems. We discover the POSIX API for shared memory and then discuss message passing in the MASH operating system. We include with Windows which interestingly uses shared memory as a mechanism for providing certain types of messaging passing. An example of POSIX shared memory. Several IPC mechanisms are available for POSIX system, including shared memory and message passing. Here, we explore the POSIX API for shared memory. An example of MASH. As an example of passing, we next consider the MASH operating system. You may recall that we introduced MASH in Chapter 2 as a part of the Mac OS X operating system. The MASH kernel supports the creation and destruction of multiple tasks, which are similar to processes but have multiple threads of controls and fewer associated resources. An example of Windows. The Windows operating system is an example of modern design that employs modularity to increase functionality and decrease the time needed to implement new features. Windows provides support for multiple operating environments or subsystem.